So as Paul noted, I'm Todd Thorson from Microsoft IT. So I'm the IT guy that everybody hates, so I can't really talk about Microsoft's products and services. I'm just going to talk about what we're trying to do from an IT group and how we're trying to move the needle forward with V6. So quickly, just the agenda that we've got. I'm going to go over our network, just an overview quickly. We'll go through why and when we did Dualstack, how it's a pain in the butt, and then we're going to move on to how we're trying to move to V6 only, some of the future looks that we're looking at what networks we want to actually deploy this to, and then some of the quick early lessons learned that we got from trying to do V6 only. So if you look at the corporate network for Microsoft, we have there's over 790 sites. 467 of them are actually what we would consider sales offices. So this is where we're focused for V6 only. It's all about the knowledge workers. It's not so much about the development side yet. That's where we want to head, but we're going to start with the knowledge workers because we think we can actually address some of their needs easier. We are in 2 ASs from our corporate network. Our Puget Sound up in the Seattle area is our main campus, 113 buildings. It's got well over half of our Microsoft employees. So it's a pretty good sized campus area. We also have 4 data centers left. They are continuing to get smaller and smaller as we move more and more to the cloud for services that have been hosted out of these. They're in their own BGP They actually follow the model that we built cloud to, so they use eBGP, and they also are a Kloss fabric. Anybody know if Charles Kloss is still alive? He's got to be dancing in his shoes or whatever he's got left, because we're still using his stuff from the 50s. When you look at our backbone, what we've deployed to support our corporate network, we buy only waves, lit waves, from as much as we can from our sister organization, Azure, or the online services group. And where we cannot get those, we buy them from carriers. We decided to go down this road because we want to simplify our backbone as much as we could. It's mostly 10 gig. There are a few 100 gig links where we really needed capacity, particularly in the Washington State area between data centers and our main campus. It is dual stack, and 3 years ago we bit the bullet and moved away from OSPF v2, v3 and moved to IS to IS, mainly because we wanted single topology for all of our, that's one of the reasons, for v4 and v6. We also wanted to separate out our backbone IGP from our, say, campus and or smaller locations IGP. If you look at those 460-odd sales offices, almost all of them are connected via carrier MPLS, layer 3 services, again, dual stack. That was a lot of work to get the carriers to do dual stack, and that's been in place for a number of years. So it took us a while to get them to actually listen to us. Wireless is becoming our predominant transport for all of our offices, specifically around, again, the knowledge workers. So us IT guys and gals, sales, support, that kind of the non-development world. We do have a fairly large wireless network. It's almost 2,700 million square feet of coverage. That does not include the data centers that Azure runs. It might include the small little piece for site services in a data center complex, but not the data center itself. We are on flight for moving to all AC by the end of the summer. We're about 60% done now. So it's, we're an IT shop. We continually have to upgrade. We continually have to beg for money, all those kinds of things. So it's certainly something we're trying to address, because if we use wireless as our primary transport, we need to make sure we've got the best and that we can get. About 110,000 Microsoft employees, and then you put all the contingency staff, the vendors, and all the support environments around that, it gets up almost close to 200K. It's a lot of people. It's a lot of stuff on the network. We are at a little under 1,900 line of business applications to support Microsoft as a whole. We're quickly moving as many of those to the cloud as we can. I think we're in about 50% range of those now. We expect some of those will never move because they just don't want to, but we don't have control over that as the networking guys. In March, we saw a little over 1.2 million devices on our corporate network. The reason that's so big is because our corporate network is also our transport for a lot of our lab infrastructure. So the development side of our world is fairly large. Just in Puget Sound, we have about 600 labs, and they range from fairly extensive data center size labs to some guy's got something built in the corner of his office. We also, from a corporate network to the rest of the world, have 13 peering points around the globe, and we peer wherever possible with our online AS, which is 8075, which is great for an IT shop because it's free. We got free internet access because they move terabytes and terabytes of data, and we're in the maybe 80 to 90 gigabits, so we're just noise to them. But it is great because we don't have to pay for egress. So let's talk about what we did from a dual stack perspective and how that's leading into v6 only, because that's obviously where we want to go as an organization, as trying to be part of this industry leading to get away from v4 and dual stack. We actually started dual stack way back in 2001 when research was building the experimental stack for XP. So they came to IT and said, hey, we're going to make this stack and we need some v6 connectivity. So we're like, great, we can do that, we think. We did it as an overlay because we didn't really want to blow up the v4 environment. And we did it with Cisco 7206s with NPE 150. Yeah, let's just say it wasn't very fast, but it got the job done for them to do what they needed to do. It was, I think, 5 or 6 buildings on our Puget Sound campus between research and the development side to get that built. In 2006, this all started because, again, development came to us and said, hey, we're rewriting the stack. We want to have a whole bunch of v6 available on our corporate network so that we can run a bunch of tests, we can validate scenarios. So we said, great, we would love to do that. Our hardware is not going to support v6 in hardware. In silicon, it's all in software. So if you guys want to write us a check, sure, we'll be happy to do that. So a guy named Joad Kaki said, deal. So they gave us about $1 million to upgrade our supervisors and our 6500s around campus, which again, as an IT shop, that's great. We didn't have to pay for it. The research network that we built to support the experimental stack was done with 6-bone addressing, which got deprecated. So we, as an IT organization, went out to 3 of the registries and got address space so that we could leverage that. Azure has got, we share some of it. They've got a bunch more. But this is primarily the 3 address blocks that we leverage. We did, 2005, an RFC came out. Microsoft was part of it. Dave Thaler was part of the guys that wrote it for ISOTAP. And we're like, great, we're the IT shop. Let's run some dog food. Let's do that ourselves. Yeah, that probably wasn't such a good idea. We did it on Windows to start with, and I'll get on later why that was a really bad idea. And then we moved it to network gear. But in our large development centers, so our Puget Sound campus, some Beijing, Hyderabad, Bangalore, the Cambridges, so Cambridge, Massachusetts, Cambridge, UK, and Haifa all got dual stack enabled, and we used ISOTAP to get in between them if we didn't enable pieces between it. And I did talk about that we did get hardware upgrade to support this from the development community. If you go back to 2011, it became apparent that Azure was going to need all of our v4 public space. We had actually leveraged public space on our corporate network, so we went merrily about our way and moved away from that public space to RF 1918 space and gave almost all of that public space to Azure. Not that it was enough for them, but it meant that we had to live without a lot of public space. So we, again, another reason to move away from v4. 1918 space is an issue for us and for Azure, just like any large cloud or hosting provider realizes that it's not enough. And you throw IT in there and they want it too. How do we deal with it? We overlap. And it makes communication between the networks that are part of our online services and the IT network a challenge, because you either have to do some kind of crazy two-way NAT or, oh gee, maybe we could use v6. What a novel idea. In 2013, we actually upgraded the edge of our corporate network to the internet to v6 or to Dualstack. And shortly afterwards, one of the reasons we did it was because we could see what was coming with O365. They enabled v6, and it pretty much so blew up our edge because we listened to the vendor and we probably didn't test it good enough that some of the v6 stuff ended up being done in software and not in hardware. So over a weekend, we doubled the number of firewalls we leveraged. I think we went from 6 to 12 to support this, and we actually pulled v6 off. So it was a separate path from v4, which is a really bad idea, but you got to do what you got to do sometimes. What really happened last year was we've gotten our leadership and our executives to think about this as a strategic initiative, that v6 is important to us as an industry, it's important to us as a corporation, it's important to us as an IT shop, it's important to us as a cloud hosting provider. So they kind of all got on board. Particularly our CIO is very good at managing up, and got us a lot of resources and a lot of support to actually finish doing Dualstack around the world. Obviously, there are a few locations where we haven't enabled v6. Building management, we just didn't touch. There are some labs that we blew up when we deployed v6 because they weren't quite ready for it. So we've got some labs that either had some older hardware in it that really weren't capable, or they didn't see the need for v6 at the moment because they needed to test in a v4 world. And we will continue to see those for a long time, as long as we continue to develop with v4 as part of the stack. So that's kind of what we did from a dual stack perspective. So we are dual stack everywhere that we possibly can. And some of the things that we learned about it was dual stack is hard. One of the first things our help desk would do when somebody called about connectivity issues, they'd turn off v6. If it fixed the problem, they'd close the ticket and move on. And then we, as an IT networking team, really didn't know why they closed that ticket. We didn't get any forensics. We didn't get any information. Did we miss a link? Did we do something wrong? Do we have an application issue? So that was hard for us to try and troubleshoot and keep track of why they were turning off v6. It is two stacks, so that's what they like to do. I'm old enough where I deployed v4 on an IPX network. Same thing. It sucked. Also, from an operations perspective, if we needed to bleed traffic off of a dirty link, the ops team would go in and take the IGP metric and move it, but they'd only do v4. And so there was those challenges about continually to train the operations team, because it is a fairly high turnover environment, to, okay, not only you have to think about v4, but you got to think about v6, and you got to think about them at the same time. So that was that's always been a challenge for us. And I don't know how other dual stack people feel about it, but for us as an IT shop, it's always been a challenge. Addressing. Yeah, we're in our third rendition of addressing. I think it's our last. But there are some really good books out there, and we didn't read them. We should have. But we made some mistakes, but we figured out how to get around them. So we think we're pretty solid on our addressing plan. And we needed to make sure that when we can aggregate, we always should. Today, a 48/48 is probably as low as you're going to get from an advertisement into the Big I. Even though last week I was at the North American v6 Summit, and I heard some grumblings about, is that going to blow up our route tables eventually? So we'll have to see how that all plays out, but obviously aggregation is important when you advertise out of your environment. Transition technologies are hard. This is a little bit of a Todd view and not necessarily a Microsoft view. Tunneling sucks. Just does. We blew some stuff up with ISOTAP, as I said earlier. We had deployed ISOTAP on Windows servers, and right at what we call RTM, so the Windows build team, were getting ready to release to manufacturing the next set of OS, and somebody did a policy change on the build servers and turned off ISOTAP, which meant those poor little Windows ISOTAP routers were a little too busy, and so we stopped builds for about 2 days. That wasn't a good. I'm glad I didn't have to get up in front of Bill at the time and explain that one. So we quickly learned from that, and we moved them off of Windows infrastructure and onto network gear that we could actually do it in silicon. So that was helpful. Still, though, it's hard to support. It's hard to troubleshoot, and it's just hard to have in your network. So if you can avoid them, we would like to have gone back and certainly avoided them in this case. Also, we found that we thought we tested our hardware appropriately, and we thought we knew what was going to happen when v6 was turned on. We missed one where we didn't think this was going to happen, but a lot of our traffic inside a corporate network was host-to-host IPsec encapsulated, so ESP null. Somebody did a policy change. Interesting how these are all policy changes and not the network guys causing the problems. Somebody did a policy change and turned that to AH, which, okay, now it's not only encrypted. Well, the hardware platform we had at the time, the silicon did not know what to do with that particular extended piece in the header, so it punted it to the processor. Yeah, so all of a sudden, we're getting lots of calls about performance. We're seeing a ton of alarms coming in about high CPU. Took us a little while to figure it out, but we realized that a policy change had screwed up the network again. So, but we never tested for that. We never thought we would see that on our network. So we learned a lesson there to, if it's possible, we should probably maybe test for it. Something we really learned from that one. Okay, so we're dual stack. We got lots of problems with dual stack. What's next? v6 only. This is where we got to go. And you know, what's cool is we're not the only ones trying to get there. Cisco has put up a building that's v6 only, and I know Comcast is building a new, I guess it's a building, I don't know exactly what. It's their headquarters or something, and they want to do v6 only. So it's pretty cool that there are more than just us trying to get to this little piece of the puzzle. One of my colleagues, IoT doesn't mean Internet of Things to her, it means Internet of Trillions. I saw a graph last week that said by 2020 there's going to be 50 billion IP addressable devices out there. You can't do that with v4. You just can't. In our world, we got these crazy little micro-herb greenhouses in all of our cafeterias. They're managed by IP, and they're tracked by IP. We got cameras all over the place. We got badge readers. We got telephones. It's all IP. It's coming. We might as well jump on the bandwagon. So that's kind of that's one of our drivers, is we see industry-wise, this is where we have to go, or we will fail. So let's get on it early. Again, that comes back to having some pretty good IT leadership that's in agreement with us crazy network guys. So it's where we're headed. Also, industry pressure. What Apple did in 2015 meant that, maybe we better start thinking about this. Microsoft has about 87 apps on the Apple Store. We probably should make sure we can support it so all you guys with iPhones, O365 actually works, or whatever else you want to use. We've talked about v4 depletion, particularly public, and the challenge we have with RF18 space. I've been in a couple acquisitions, and it's just a pain in the butt when we were using the exact same address space on both sides, and to try and get a communication across that. How does that work? Two-way NAT's always fun to deal with. We did talk about operational complexity of dual stack and continually having to train the ops team, because as you get new operators that help from an ops perspective, oftentimes they've never even seen v6. So it's something we continually have to train on, and it is a continual challenge. Not that it won't be a challenge in the future, because, well, they still might not have v6, but they don't have to worry about dual stack. Don't have to worry about v4 and v6. What is the problem? Is it v4? Do we have a v6 problem? Who knows? And back to strategic goal that our leadership has signed up for us to become, to try and help lead this direction, and look at v6 only as a solution to move forward with. So what we're doing today to move forward with v6. We have a number of test networks up, particularly in our Puget Sound area, in our IT buildings, mostly. We do have a guest wireless network that we're thinking about. Maybe that's someplace we could certainly try this out first. I have my reservations about that, but we'll see. We also have a wired and wireless corporate network set up in our IT buildings so that we can continue to test and learn from some of the challenges associated with just v6 only. And of course, to support that, we have deployed DNS 6.4 and NAT 6.4. Back to the Apple release, we do have a few v6 only networks for our development community, Skype in particular. So we've deployed it in Europe and a couple places in North America to try and at least give them a test bed, so where they can continue to test in a v6 only world while they still have access to a dual stack when they need it. I think one of the hardest challenges we'll have, and I'll get to this in a little bit, is address acquisition and DNS. We use Slack. We use Slack with our DNSS. We use DHCP stateful, and we use DHCP stateless. Another Todd comment is, I would like to just use one, but unfortunately our world will require us to use probably all of the above. And it comes down to what clients support, what our security guys are happy with, which they're still struggling with how to wrap their arms around v6 and the security mechanisms that they want to use there. But certainly for our guest network, right now it'll be DHCP v6 stateless and Slack, and our DNSS to support Android phones, because they don't support DHCP. So it is a challenge when you think about addressing. V4 was a little simpler. You just bring up a DHCP server and you were done. Not so much here. And the Microsoft stance is DHCP stateless and Slack. So that's certainly one of the models we will leverage considerably along this. Another thing that complicates this a little bit further is we have two other initiatives that we are driving towards, so they kind of all are intertwined. Is we have an internet first, as I talked earlier about wireless becoming our primary transport, particularly for the knowledge users. And we're going to get rid of as many wired ports as we can. They're expensive. We don't use them a lot. So why do we keep deploying them? Why do we keep deploying wires to every desk? Those kinds of things, every cube, whatever it is. We also have another one initiative called Internet First. And if all the services that a client or an end user has on the Microsoft network sit in the cloud, why are we backhauling that traffic to a central location, one of those 13, and sending it back out to the internet? There could be going just down the street from them. In Amsterdam, for example, we got a fairly good-sized office in Schiphol, and we have a whole bunch of services sitting in the Amsterdam data center for Azure, but they go all the way to London or Dublin to come back to Amsterdam. So we're looking at models that we can do internet for a site, get them out to Azure as quickly as possible, and then we got to tack on, okay, let's do that with v6 only. So there's some challenges there that I'll touch on in a little bit. So I need to touch on this, is we're looking at doing wireless guests first. And just Friday, I was in a meeting, and we are still debating this, and rightfully so, I think we should. Because we want to know what's going to break when we do this. And our guest wireless is a very, very consistent network, unlike the rest of our world, where it looks the same everywhere across the planet. It's the same type of network. It has the same functionality. It has a smaller application portfolio that we would have to deal with. But as we all found out, whose VPN actually worked in a v6 only world? That's going to be a stickler for us. So we'll have to continue to work on that. But we do think that this is a possibility for us to do something first here, because we will learn, certainly for what we could do for our internal deployments. Supposedly it has a lower SLA than our corporate network, but when guest wireless doesn't work, there's usually somebody calling us that's certainly at a higher pay grade than me. So it's, I don't know if I completely agree that that one's going to be valid or not, but we do want to move fast, we want to learn fast, we want to fail fast, and we want to fix fast. That whole agile model that we want to really try, and we think this might be a network that we could do this on. We will see. This is certainly one of our ideas. As we move forward, obviously we're going to have to continue to deploy NAT 6.4 and DNS 6.4 just because of the nature of the beast. That v4 tail, it's going to go well past my career that v4 is going to be around, so something we're going to have. We want to move the guest from a pilot into production in a few spots just to start learning about that. And then we do want to take what we've done with the guest and what we've learned there and pilot it on our corporate network. And where I think we're going to end up is most of IT in the Redmond, Puget Sound area is in a very small 5-building campus. It's a perfect place for us to just turn on v6, turn off v4, and watch and see what happens and see how bad it gets. But obviously, once we go down this road, we don't want to go back. So we're going to have to make sure that when we're ready to deploy v6 only, that's the model we move forward with, and we'll have to just live through the pain and not have v4 available to us anymore. As I said earlier, trying to bring this v6 only into our internet first strategy. How do you go to the internet and the services that sit there, do they meet our needs when v4 isn't around? That's something that we're a little concerned about because we already see problems and we're not very far down the road. Once we've figured that piece out, and then we start actually really understanding how we can deploy to our knowledge workers and not so much the development, then we will take a step back and say, okay, let's look at our infrastructure. How do we manage our infrastructure? Today it's all v4. Let's start looking at how we can manage that via v6, and then turn our focus to the development community and how do we deal with them. Because there are pieces to that world where they will always need dual stack, they will always need v4 as long as they continue to test. And since we support a lot of their test environment, that's something we will continue to live with. It also gives us an opportunity. Microsoft IT does a lot of what we call showcases, where we say, this is how Microsoft runs IT to a lot of our customers. This will give us an opportunity to tell them about how we're trying to move v6 to a v6 only world, and hopefully evangelize that and get them all excited and get them on board to try and go down this road along with us. So that's some of the future we want to look at. I want to touch a couple things on DNS in particular and the resolver challenges we have. When this deck was written, the creators release hadn't come out yet, so which it now has, and it actually includes support for RDNSS. So finally, we've gotten Thaler to agree to that. So that does help us in one way going forward, that Windows will also support that DNS model, but I have no idea if it's going to get backported to any other version of Windows. So it will, time will tell, but it does mean we're going to have to continue to support DHCP v6 and Slack and RDNSS. So it's a model we're going to live in. It's a model we're going to live in for a long time. Part of the problem that we have with this is some of the routers that we leverage for our building routers don't today support RDNSS. So how do we get around that? We're getting code from the vendor to fix that, we hope. Should be in our hands this week or maybe next, so then we can start testing and start deploying. But when there are a few thousand of those routers, it takes us a little while to actually deploy. And if we need to get this up sooner, then we're actually going to have to look at some kind of overlay to provide those services to a building from a central pair of routers that both are the DHCP relay and that can actually run our DNSS. I'm hoping we don't have to go down that road, that we can stall long enough to get the right code in place and not have to actually try and build an overlay again, which this overlay would not work in our remote locations where it's a carrier-based layer 3 VPN. Then we'd have to run something else like GRE or VXLAN or some other overlay technology that I would prefer not to do. It just complicates the matter even more. So, and then if we can, some of the early lessons learned we've learned that carriers may be able to transport your data via V4 or V6, but it doesn't mean the services that they can also provide are V6 enabled. Same thing with a cloud provider. Azure is not completely there yet. They're working on it. It's super high on their priority list. So we're seeing all that start to come to fruition. But today, there are pieces to the puzzle where we know it just doesn't work. So when you think about going internet first and V6 only, we're running into some challenges here around security, around functionality. Do our applications, how much NAT 6.4 are we going to have to do? And where do we deploy NAT 6.4? Because our model is going to change as we move down this road. And like I said, NAT 6.4, DNS 6.4 is going to be with us for a long time. That V4 tail is going to be long. So we get to just get to know them well. And I hate to bring this up, but NAT 6.6 is also part of the puzzle. Today, we actually do NAT 6.6 at our egress edges. We did it because of financial reasons. We knew how to solve this problem. We just didn't have the money to do it. So it is in our world today that we just do a standard NAT 6.6, nothing fancy. It helped with stateful firewalls and symmetry, but one of the reasons to go to V6 was to not have to do NAT anymore. Well, we haven't quite gotten there yet. So we do have a plan. It's just not completely high enough on our list yet to go tackle. But it is part of our world, and it probably will be, well, Paul says part of their world too, so we're not the only ones. And the last piece I want to leave you with is the client side. Client services, are they ready for V6? You can go out to the print vendors and say, hey, you guys support V6. You support DHCP V6, you support Slack, you support RDNSS. And they might all raise their hands and say, sure, yeah, I'd probably test it, because I don't know if that's really, really true. Because we've learned, we learned a lesson a few times. Client manageability. How do you manage your clients? Can you manage them by V6 only without any V4 connectivity at all? So are they AD joined? Is your AD infrastructure V6 completely V6 ready? Intune, all these other ways to manage your infrastructure. Can it go completely V6? Something else we're working on, we're testing, we're trying to understand where the ramifications are to that. And then, of course, there's the client security. How do you secure your client with just V6? I think the security guys are a little freaked out about it, at least in my world, because they've been so used to having the V4 functionality that they've had, and they know how it works. They know the models to build to. This is something a little new for them that they're continuing to have to understand, learn, and get on board and move down this road. So those are some of the quick lessons we've learned in the past few months about what our challenges are with V6 only. With that, I'm done. Thank you.
Questions?
Great talk.
Thank you.
About Internet of Things, you mentioned that we don't have enough IPv4 addresses for all of these trillions of devices. So what is your experience with these security cameras, and other things? How is the IPv6 stack support there?
So I think that's a long-term view. Obviously, there's some of that infrastructure that we still leverage v4 with, but I think as we go down this road and we look at more and more sensors, more and more models of devices that give us information. For example, we've got a really large parking garage. Wouldn't it be great as you drive in, you got a sensor that says, okay, I know who you are. You work in building 3. There's a parking spot right over next to building 3. Go there. That's what I think is going to happen. We're not there yet. A lot of that stuff is still managed via v4. We can do it with NAT, but is that really the right model? Yeah.
Makes sense. Thanks.
Yeah, you provide happy eyeball support and all the hosts. For example, you do v6, and if it doesn't go through, you try for v4. Is it sort of implied? I mean, did you encounter any problems with the happy eyeballs? And
not that I'm aware of, though. Last week there was at the North American v6 Summit, happy eyeballs came up quite a bit in a v6 only world. Is it something we need to continue to have, or should we have some hooks in the browsers that says, I want to turn that off now? So I haven't seen any problems with it. So doesn't mean it's not there. We're just not aware of it.
I could add a comment about that. Happy eyeballs doesn't work in a v6 only environment because you only end up getting a synthesized DNS 6.4 response if you don't have a quad A record. And so, for instance, T-Mobile runs into this quite often with broken government websites where because the government has a mandate to have everything be accessible over v6, but then they don't actually test that their v6 is up. And so then when you actually try to connect to this on a v6 only network, it ends up never falling back to v4 because it has no way to speak v4.
Yeah, what he said.
Thanks. I was wondering what the if you could talk a little bit about the tooling and the software automation that you used. In particular, you mentioned like the NAT66 stuff for symmetry. You mentioned financial considerations, but I was wondering if was that actually more of a tooling question to try to just maintain symmetry across your automation? Just the tooling automation in general.
So the NAT66 piece was around, we had a mandate from our security team that said we had to have stateful firewalls. We couldn't do stateless. And so we knew we needed to get that traffic back to the same location. We could have done it with some extra hardware to make not an overlay, but another ring of the network so that we could control that, but we just didn't have the funding to do it. So that really wasn't a tooling problem, that was a security mandate. As far as tooling goes, wherever we can, we buy off-the-shelf tools because we're an IT shop and we generally don't have the expertise to go build it. We are trying to steal some of the stuff from Azure because they write some pretty good tools. But we haven't come across an issue that would stop us from a tooling perspective. But we haven't really addressed manageability via v6. We're still leaving that as a to-do, and we're focused more on the client traffic more than the manageability piece.
Martin Levy here at Cloudflare. Over here. So I'm going to use as an example, but only randomly. Chrome is going to radically change the way that they do their green bar for secure sites. And I think this is for the better. And they're actually going to turn around essentially and say, this site is insecure. Based upon the work you've done, does Microsoft have a strong enough conviction to start making their operating system platform tell the user, you are not on a valid network. It is v4 only. And sort of, really start pushing this all the way out to the end user. I'd say the same to Apple, I'd say the same to Android, but you're on stage, so I say it to you. This is a very strong position to take, but I used the Chrome example of this site is insecure as sort of a statement to the industry that we're not going to stand for these old style methodologies of, in this case, insecure or v4, etc. Thoughts?
So personally, the Todd view is I think that's a great step forward in making sure that we do have secure transport to our applications and our services. I can't really tell you the Microsoft view because I'm the IT guy and I don't want to get in trouble for saying something I shouldn't. But I agree with you. I think it's really important. And I will certainly take that back to my leadership to say, hey, are you guys aware of this? They're probably not. And see if we can as an IT shop, evangelize that into our product teams. Because they sometimes listen to us. I mean, we're a customer of Microsoft, and sometimes we're listened to and sometimes we're not. But it's a really good point.
Any more questions? All right, thank you, Todd.
Great, thank you.